Hello everyone, welcome back to my YouTube channel. Today I'm going to discuss about a verilog behavioral description for BCD upcounters. Table of contents includes introduction, designing a BCD upcounters, behavioral modeling of flip-flops, behavioral modeling of combinational logic, understanding the BCD upcounter behavior, building the flip-flop functionality, implementing the combinational logic, simulating and testing the BCD upcounters, and conclusion. Let us discuss one by one. Introduction to Verilog behavioral description for BCD upcounters. Verilog is a hardware description language used for designing digital systems. Behavioral description allows us to model the behavior of a BCD upcounter using Verilog. BCD upcounters are used to count in binary coded decimal format in an upward direction. Designing a BCD upcounter. A BCD upcounter consists of flip-flops and combinational logic. Flip-flops store the current count value, while combinational logic determines the next count value based on the current count and control inputs. We will use behavioral modeling to describe the functionality of each component. Here is a BCD ripple counter. Here we used JK flip-flops. Behavioral modeling of flip-flops. Flip-flops can be modeled using always blocks in Verilog. We will use non-blocking assignments to describe the behavior of flip-flops. The sensitivity list of the always block will include the clock signal. Behavioral modeling of combinational logic. Combinational logic can be modeled using procedural blocks in Verilog. We will use the blocking assignments that is equal to describe the behavior of combinational logic. The behavior of combinational logic will depend on the current count and control inputs. Understanding the BCD upcounter's behavior. BCD upcounters increment the count value by 1 in an upward direction. The count value ranges from 0 to 9 in BCD format. When the count value reaches 9, it wraps around to 0. Designing the BCD upcounters module. The BCD upcounter module will have inputs for control signals and outputs for the count value. We will define the required inputs and outputs using Verilog module declaration. The behavioral description will be implemented within the module itself. Building the flip-flop functionality. We will use flip-flops to store the current count value. The next count value will be determined by the control signals and the current count value. Each flip-flops will have its own always block to describe its behavior. Implementing the combinational logic. Combinational logic will determine the next count value based on the current count and control inputs. We will use a procedure block to describe the behavior of the combinational logic. The output of the combinational logic will be connected to the input of the flip-flops. Here's a combinational logic circuit diagram and its truth table. Simulating and testing the BCD upcounters. Simulate and BCD upcounter using Verilog simulation tools. Verify that the counter increments correctly in the BCD format. Test different control inputs to ensure proper functionality. Conclusion. Verilog behavioral description allows us to model the behavior of BCD upcounters Flip-flops and combinational logic are used to implement the functionality, simulate and test the design to ensure correct operation. Thank you for watching the complete video. Please do like, share and subscribe to my channel. Thank you.